The disease that we are testing is Alzheimer's. Alzheimer's is a progressive brain disease. It causes problems with memory, thinking, and behavior. 5.5 million Americans are expected to have Alzheimer's. It is the sixth leading cause of death in the U.S. 60 to 80% of Alzheimer's cases have a genetic cause. There are two types of Alzheimer's disease, early onset and late onset. Early onset is before age 65, late onset is after. Early onset Alzheimer's is formed from the mutations of the genes APP, PSEN1, and PSEN2. When these genes are mutated, they produce large amounts of toxic protein in the brain called amyloid beta peptide. These then build clumps called amyloid plaques, which are a characteristic of Alzheimer's. These gene mutations are located in the brain. The APOE gene codes for a higher risk for late onset Alzheimer's. It does make sense that variations that change the structure or gene expression of these proteins alter Alzheimer's, because the amyloid plaques are what characterize Alzheimer's as Alzheimer's.
According to SNPpedia.com, the genes that contribute to Alzheimer's disease are APP, whose RS number is 63750847, APOE RS number 429358, POD3, TREM2, and TM2D3. An RS number is a number used to help identify specific locations on the genome. All of the genes aside from APP, which is suspected to protect people against Alzheimer's, increase the risk of Alzheimer's disease. SNPpedia also states that both APOE and TREM2 are reported to have the most increased notable risk of AD, whereas all other listed SNPs have lower risk. Therefore, these two genes would be the most reliable predictors. The APOE gene makes proteins that are responsible for removing cholesterol out of the bloodstream. It makes sense that an effect in the cholesterol metabolism could affect Alzheimer's because there is a link between high cholesterol and cognitive decline, which can contribute to Alzheimer's disease. The allele C in the APOE gene contributes to Alzheimer's, and the T is the normal allele. Having at least one of the C alleles can increase the risk of AD up to 3 times. TREM2 proteins are responsible for triggering receptors on myeloid cells. These cells are affiliated with dendritic cell formation, which impacts the immune system and its responses. If the T allele is present in a patient, then they have an increased risk of getting AD. Oppositely, the C allele is the normal allele, and the risk of getting Alzheimer's with this is significantly lower.
While there are clear reasons you should use genetic testing for Alzheimer's, there are also some limitations that can make someone change their mind. The first thing to understand is the misconception that testing for Alzheimer's means you will be guaranteed to get it or not. This is because only 2% of people with Alzheimer's actually have a mutation in a gene that directly causes the disease. The genes that you would most likely test positive for are called risk factor genes. Such genes as the APOE E4 occur in a majority of people who do end up developing Alzheimer's, but oftentimes people with 2 of the genes lead healthy lives. Same goes with people without APOE E4 who become ill. Another limitation to the testing is that lifestyle risks such as obesity, hypertension, or diabetes can impact your chance of Alzheimer's due to having a mutation in one or more of these genes. The fact is that the factors leading to Alzheimer's, aside from the extremely rare cases, are too complicated for accurate testing. Even if you go on to test, the repercussions can haunt you. The government does not currently protect against discrimination when people purchase long-term care, life, or disability insurance. This means that insurance companies can use a positive test result to charge you incredibly inflated rates that might not be affordable to most people.